In this video, we're going to look at sets and all about different types of set notations and what different types of sets are. So a set it's a collection of objects, and that's all there is to it. In a math course, typically it refers to a collection of numbers. Generally, a set is just a collection of items. Members of this set are called elements. Anything in your set is called an element. Finite means countable. So a finite set has a countable number of elements. It could be a very large number, but it's still countable. Versus an infinite set, which has infinitely many elements. So uncountable. Sometimes in math you need to use a notation that describes a combination of two sets, and the most typical combination or common one is called a union. So a union of two sets is the set of all the elements that it's in at least one of the two sets. So it's where they, it's like if you have a set A and a set B, the union of two sets is the set of A and B. It's everything that's in one or the other, at least one or the other. So it's a set of elements in at least one of the sets. Okay. If a set has a finite number of objects in it, it could be described in words, or you can use this notation called roster notation, which is essentially where you just list things out. You list out all of the elements in the set. Typically, it's done inside of curly braces. So, for example, the set of all billiard balls is numbered 1 through 15. So in roster notation, you always open with the curly brace that indicates that you're referring to a set. So it would be the set of elements 1, 2, 3, 4, and you can write them all out, or you can just put a little ... once the pattern is established onto the last one. Okay, if A is the set containing the numbers 1, 3, 5, and 8, and B is the set containing the numbers 3, 5, and 7, find A union B. So this big wide U, it's got a wider base than a regular U, refers to union. It's shorthand for union. Okay, and you can put it in between two names of sets. So typically sets are named with letters. It's just very common. So if I say find A union B, that means find the set of elements that are in at least one of the sets. So let's see, and we're going to go in order here. So let's start with a 1 because it's in set A. The next number that appears is 3, which is in both sets, but we would only list it once. It would just be redundant to put the number more than once. The number 5 is in at least one of the sets. Next is the 7, set 8, and then 8 in set, excuse me, 7 in set B, and then 8 in set A. So that's the A union B. The set of all elements that's in at least one of the two sets. So some infinite sets, though, for example, such as real numbers, that would be just any non-imaginary number, cannot actually be represented in roster notation because it would be impossible to list them all out. Right? You can't actually write out infinitely many numbers. You'd be writing forever. So instead, there's other ways to describe infinite sets. The set of real numbers, for example, just all the numbers from negative infinity to positive infinity, could be represented by a simple number line. Okay, usually negative infinity is on the left, positive numbers are to the right, and you could put a few markings if you wanted to. 1, 2, and so on, -1, -2. Also, just so you know, shorthand for the set of all real numbers is a capital R with a double bar. It's shorthand for all the real numbers. Okay, inequalities is the next notation type, and it's a good way to represent typically sets that are infinite, and it's usually used to represent real numbers that are between two other numbers. For example, the set of real numbers between 3 and 5, well, that's an infinite set because there's infinitely many decimal numbers and fractions in between 3 and 5. You know, there's 3.1, 3.05178334. There's 4.5. You know, there's infinitely many little numbers in between them, so you couldn't list them all out. Okay, if you just tried to write 3, 4, 5, that would be incorrect because those are integers. So instead, we can represent that set of numbers either by a number line or an inequality. So if you're going to represent some numbers on the number line, it's typical to draw the arrows on both ends. And let's see, we're going to represent numbers between 3 and 5. So I'll just go from 2 to 6. It's just implied that, you know, we go on beyond that. Okay, between 3 and 5, that implies that we are not including 3 and 5. So everything right up to 3 and right up to 5, but not including them. So there's two ways to do that on an inequality. You could put an open circle. I think that's the most common way. The other way to write it would be to put a little parenthesis. I'm going to go with an open circle at 3, and then you would shade this in. If you have another color, oops, went too far there. If you have another color pencil or pen of a different color, that helps if you're shading with a different color than your number line. Okay, so that's how we could represent the set of real numbers between 3 and 5 on a number line. Or in an inequality, you would actually say, you give it a variable name. Okay, I'm going to use x because that's most common. X is between 3 and 5, so that means x has to be greater than 3, but less than 5. And notice how the direction of these inequality signs, okay, they're both less than signs. But when you look at this, the big side of this mouse is open to the bigger number. So in other words, x is greater than 3 is one way to read that. You could turn it around and say x greater than 3. And over here, this part says x is less than 5. Okay, so this is actually another way to write that set right there. It's just to put an and, which has to do with intersections, which is different than unions. Okay, you wouldn't say x greater than 3 union x less than 5 because that would mean all the numbers in either set. Well, all the numbers greater than 3, that's from 3 on up to infinity, and all the numbers less than 5, that's from 5 down to negative infinity. So that would just be all real numbers if you tried to put a union here. So the word and is very important there. But this would be the more common way to write such an inequality, and that's as a compound inequality. It's always done in this order with the smallest number on the left, a less than sign, a variable, and then if x is between two numbers, you would have another less than sign and the greater number on that end. If we were including the endpoints, you would color in, okay, those dots, if we were including it, and you would put a little equal to underneath that inequality sign, okay, to include the endpoint. But in this problem, we're not including the endpoint. Okay, another notation type is called interval notation. An interval is exactly what we were just dealing with. It's a set of real numbers. Interval notation only works with real numbers, not integers. Integers being your countable numbers, 1, 2, 3, 4. Okay, it's a set of real numbers between two numbers, typically. Okay, in interval notation, the symbol with a bracket. Brackets are used to include an endpoint, and the symbols parentheses are used to exclude including endpoint. So for example, this means the set of all real numbers between 4 and 6, including 4 because we've got that equal to sign, but not including 6. So in interval notation, we start at 4, so we're going to start with a bracket and 4 because we are including 4. Then you put a comma and you put the ending number, the greater number, in this case 6. And since we're not including 6, there's no equal to sign, we'll put a parenthesis there to exclude that. Okay, that's interval notation. It's just, you don't actually have the variable x. It's just the number, comma, the other number. And you have to have either a bracket or a parenthesis. One thing that can be confusing, make a note here, is if you are not including either endpoint. So for example, if I put 3, 5, you have to understand from the context of what it is you're doing in the problem as to whether this means the interval from 3 to 5 and all the x values in between 3 and 5, or if that means the coordinate point x is 3, y is 5, which is probably what you're more used to seeing. But those have two very different meanings but the same notation, so you'll need to be careful with that. Okay, let's look at this next example, and I recommend that you pause the video and try this on your own, and then restart the video to see if you've got it. Okay, we want to write the set of numbers on this line right here that are graphed in interval notation. Now you always go from left to right, from low to high. So the lowest number here, the first number we hit, is -5, and that is a filled in circle, so we're going to include 5. So in interval notation, I'll put a bracket, 5, comma, then we go up to -2, and it looks like we are also including that. Okay, also there's another piece over here. So you could put a comma or you could put a union sign here. And then also the numbers greater than 3, and this arrow is highlighted in red, so that implies we're just going all the way up to infinity. But we're not including 3, so we'll put a parenthesis. And then you would put infinity here. That's the infinity sign. Technically, nothing ever equals infinity, so we always put a parenthesis whenever you're using infinity or negative infinity. Or the alternate choice here would have been to put, oops, I left off a negative sign. -5, comma, -2, comma, 3 to infinity. I'm not picky about which you put, whether you put a union or a comma sign. Okay, and the last notation type here is set builder notation, which really is a combination. It's just a little bit more specific. It's a combination of the other types of roster notation and inequality notation. Okay, so finite or infinite sets can be described in set builder notation. It's a very open notation. You can use words even with it, which is nice. Okay, let's look at this first example though. The set of striped billiard balls, which is the balls with these numbers, 9 through 15, can be represented in set builder notation. Okay, you start with your curly bracket, which means the set of. Then in set builder notation, you have to give it a variable name. So we'll just go with x, but you can make any variable you want. Use y or something. Then you say such that, which you can either describe with a colon or a long vertical bar. That's typically what I do. And then after that, you put the description of your set in terms of x. So because I'm using x, I'm going to say the set of all x such that x equals either 9, 10, 11, I'll just list them out, 12, 13, 14, 15, although I could have put a ... in there somewhere. Okay, that would be a good way to describe this in set builder notation, and I can think of one other way to do it aside from just using a different variable, but you could also say the set of all x such that x is between 9 and 15, including 9 and 15. Now the problem with just saying that is that it's implied that x is a real number, so this statement right here implies that x could be a decimal, like 9.5, right, or 10.2, which is not true. So you would also have to say where x is an integer. And just for fun, the shorthand for integer, in case you want to know, is a double bar Z. Okay. And lastly, one more example. Write the interval from -1 to 5 with brackets in set builder notation. So you would read, you would start with the set of and give it a variable notation. I'm going to give it x. So the set of all x such that, actually this one, let's use the colon because you can do either. Such that x is between -1 and 5, and you have to say that somehow using x. So because it's implied that we're in the real numbers, because anytime you use interval notation, you're in the real numbers, I'm going to use this, I'm going to describe this with an inequality and say -1 is less than or equal to x, less than or equal to 5. Okay, that's it for set notations.